Gases play a significant role in our life. We use oxygen gas for breathing and to carry out different body functions. Nitrogen gas is required by plants for their growth and maintenance. Excess of carbon dioxide in air causes global warming and several other environmental hazards. Carbon dioxide is classified as a gas. Gas is a state of matter like solids or liquids. We have already learnt about the two states of matter, that is, solids and liquids. Here, we will discuss the third state of matter, gas. To understand the behavior and effect of gases at the simplest level, let us understand their properties. Gases have very weak intermolecular forces of attraction. This enables them to move freely in a medium and acquire high kinetic energy. Gases completely occupy the space of a vessel regardless of its shape. This shows that gases neither have a definite shape nor have a definite volume. When air is blown in a balloon, it inflates the balloon within seconds. But one must ask, how does this happen? As air is passed in the balloon, the air particles move at high speeds in random directions and collide with the walls of the balloon. This exerts pressure on the balloon that makes the balloon inflate. We can thus say that gases exert pressure on the walls of the material in which they are in. The fact that gas particles are widely separated, the same mass of a gas occupies very large volume. Thus, the mass per volume or the density of gases is very low. We know that liquefied petroleum gas, or commonly known as LPG, is used for cooking food in our homes. But what is the science behind its usage? Let us understand by an activity. To perform this activity, we require 3 syringes, water and chalk pieces. Remove the piston of all the syringes. Take one syringe and close its nozzle with the help of a rubber cork, as it is already filled with air. Now, place the piston back into the syringe and try to compress it. Repeat the same activity by filling water and chalk pieces in respective syringes. Now, place the piston back into the syringes and try to compress them. What do you observe? The piston of the syringe containing air moves in easily on applying pressure. On the other hand, the piston of the syringe filled with water moves in slightly, whereas the one with chalk does not move at all. What do we conclude from this activity? The fact that the first syringe moves in easily signifies that the gases can be easily compressed. The syringe filled with water moves only slightly, meaning that liquids are only slightly compressible. On the other hand, the syringe with chalk pieces does not move, meaning that solids are completely incompressible. Now, we know that the LPG used at homes is kept compressed at high pressures in the liquid form. Once we release the nozzle, the pressure is reduced, which converts the LPG from liquid to gas. We all know that gases can easily diffuse through the medium they are in. We can smell perfume because the particles of perfume mix with the particles of air. Such a property arises due to the random motion of the perfume particles, which is a result of their weak interparticle forces of attraction. Let's discuss what we have learned so far. Gases have large interparticle spaces between each other. They have the least interparticle forces of attraction between each other. They neither have definite shape nor definite volume. They are highly compressible as compared to solids and liquids.